Welcome back, ladies and gentlemen. We are on week 9 already. This is our first lesson of the week. We are on textbook page 319. We're still in topic 6, but we're now on lesson 4. So it is going to be a new topic today. All right, let's quiz ourselves about our last topic, which was minerals. What mineral is needed to have a healthy body? Is it A, potassium, B, calcium, C, diamond, or D, A and B, so potassium and calcium? 5, 4, 3, 2, 1. I'm going to start off and eliminate diamond because although diamonds are beautiful and they probably make some people super happy, we don't need them to be technically healthy inside. I am not going to eliminate any more because we need both potassium and calcium. Remember that potassium was found in bananas, and that mineral really helps your muscles from cramping. It's very important to muscle health, and calcium is really important for our bones and teeth. So you get calcium from milk and milk products like yogurt and cheese. All right, so that is one of the uses for minerals is we need them to have a healthy body. All right, before we really get into the lesson, I want you to imagine something. Imagine that you are describing Earth, so planet Earth, to an alien, someone from out of this world, that has never seen it before. So here's our little guy. Hey, little buddy, sweet dance moves. You want to know more about Earth? All right. What would you say? What would you say about Earth to this creature that has never seen it before? Maybe you would say it's the blue planet. And the reason why it's called the blue planet is because it has a lot of water. So most of the Earth's surface is covered in water. Or maybe you would say something like it's mostly made of water. I think those are our main characteristics about planet Earth. It's, as we know, the planet that has the most water. There's a little bit of frozen water on Mars, but not as much as Earth has right now. So why am I asking you to do this? Well, because the goal of the day is to learn about water on Earth. And maybe you already know this. If you don't worry. There's two types of water on Earth. There is salt water, and there is also fresh water. So salt water, like the name says, has salt in it. And fresh water does not. Okay? So if you hear the word fresh water, it doesn't mean that it's like, crisp and cool and right out of the river. It means that there is no salt in it. We're going to take a minute to compare salt water and fresh water. And we're going to do this using this diagram of water drops. So you're going to see that majority of water drops are this kind of dark blue color, with the exception of the last 3 drops that I have circled in white. And you see that 2 are a little bit lighter blue, and then the last drop is quite a light baby blue. Okay, so let's see what this diagram represents, or let's see if we can interpret this diagram or get information out of it. Let's think back to the wow, sounded very Western New York right there. Let's think back to the dark blue drops. Those are going to represent salt water on Earth, and we're going to see that 97% of the water on Earth is actually salt water. So there's much more salt water than there is fresh water on Earth. All right, so let's move on to those little drops in that white circle. So these 2 little slightly lighter blue, that's going to represent fresh water. But this fresh water is actually stuck in ice, so it's not fresh water that we can readily use. Although with global warming, who knows, we might be able to use it sooner rather than later. And that finally, baby blue, 1 little white drop, light blue drop, is going to represent fresh water that we can use. And that's only going to represent 1% of fresh water on Earth. Or, yes, I got it right. All right, so 97% of water on Earth is salt water. 2% is fresh water that we can't use because it's trapped in ice, and 1% is fresh water that we can actually use or have access to. All right, let's talk about some problems with salt water because our Earth is mainly salt water, 97%, and that's pretty cool for creatures that live in the ocean like fish and sharks and whales and octopus, but what about us? If we were on a boat, stranded in the middle of the ocean, and we were thirsty, could we just maybe dip our head in water and just take a big couple gulps of salt water? What do you think? Is that something that we are able to do? Well, hopefully you said no. And let's learn why. If we drink salt water, like if we are stranded on an island or stuck in the ocean, there will be too much salt outside our body cells. And the issue with that is that extra salt causes water to rush out of our cells, so water moving, remember, is called osmosis, and this will make our cells shrink. So if you think back to when we learned about diffusion and osmosis, and when we did our experiment with our egg, and we put our egg in, I believe we put it in corn syrup, which also has a lot of like stuff outside of the egg, and water rushed out and shrunk our egg. Well, the same thing's going to happen with our red blood cells, which transports oxygen around our body. So the first picture is a normal red blood cell, and that's what they should look like. They kind of look like a really nice inflatable pool toy that you want to float on in your pool, or like a nice big filled donut. But if we put them in salt water, all of that nice water that kind of puffs them out will leave the cell, and the cell will shrink. And they don't work as well when they're all shriveled and shrunken like a raisin. So shrunken red blood cells can cause dehydration, which can lead to death. So we obviously don't want that to happen. Okay, so what water can we use? And again, we're going to use another diagram. We can't use salt water for drinking or cooking, so we have to use fresh water for most of the stuff that we use water for. So there is much less fresh water on Earth than salt water. We already saw that, but what can we actually use? So in general, on Earth, we've got 71% of our planet covered in water. Not all of this water we can use. We can only use about 2.5% fresh water, and we can't even use that whole 2.5% because, again, some of it is frozen in ice. So we can use, again, about 1% of that fresh water. So we're going to have to try really hard to find this water that we can actually use. So where is it? So most of our fresh water is locked up as ice in glaciers or at poles. Remember, glaciers is just a huge ice sheet. There is a tiny amount of water in the atmosphere, and atmosphere is that layer of air that surrounds Earth, but you know, it's not like we can go take a cup and get a nice cold drink of water from the atmosphere, so we can't really use that. So most of the water we use is going to be in lakes or underground. So we actually live near two Great Lakes, Lake Erie and Ontario, so we're pretty lucky, but fresh water is not evenly distributed. That means spread out around the globe. So think of a desert. So like most natural resources, which is what water is, it is not equally accessible to everyone. So not everyone is as lucky as us who lives in Buffalo with two great freshwater lakes to have access to fresh water. So that's going to create problems. Okay, we are going to wrap it up today. And we looked at a lot of diagrams, and hopefully you were able to interpret them or pull information out from them with me. So I want to know, most of the water on Earth is A, fresh water, B, found in the atmosphere, C, salt water, or D, found in lakes. 5, 4, 3, 2, 1. I'm going to eliminate found in lakes because that is the major source of fresh water. I'm also going to eliminate found in the atmosphere because that is just a teeny tiny amount of water. It doesn't make up that much of water on the earth that is found in the atmosphere. So the correct answer is salt water. Okay, so again, our planet is covered in about 70% of water. And of that, most of it is salt water, and only like 2% is fresh water. And even of that 2%, we can only use a little smidge of that. Okay, guys, that is it for today. Please be good, be healthy, and I will see you back here soon.